Okay. So, so quickly, what we did as a revision is what in the last lecture, we understood everything about the data, the statistics, the nature of statistics, population versus sample, and the measurement scale, nominal, ordinal, interval, and ratio scale. Summarizing the data, frequency distribution, a tabular distribution, where we calculated the absolute and relative frequency, and then we graphically presented the data with histogram and frequency polygon. Correct? This was the qualitative aspect of data. Now, when we go to the quantitative aspect of data, in terms of quantitative aspect, we have to focus on two things. That is the measures of central tendency, which is mean, and the dispersion around it, which is called as the deviation. So it is basically nothing but the focus of return and risk. That is what we understand from the financial perspective. So measures of central tendency and dispersion as well as location, these are the quantitative aspect of data. They will tell us some numbers, some probabilities, some percentage of the data. So in terms of measures of central tendency, what do we mean by central tendency? Let me go to that. So central tendency is nothing but it will explain us the characteristic of data, the overall quantitative aspect. It tells us the characteristics of the data. It tells us where the data is centered. So when we spread the data, when we plot the data, where the data is concentrated, it is concentrated around something, and that around is what we call as around the mean. So mean is nothing but the average. And the way to calculate mean, there are different types of mean. The one you calculate for the population and the one you calculate for the sample. The one you calculate for the population is called as mu. And the one you calculate for the sample is called as x bar. So it has a bar on it. Now, the way to calculate is arithmetic or geometric. Arithmetic is simple average, where you take the summation of all the data divided by n. Geometric is where you compound. So when you are going to invest for 5-6 years on a compounded basis, then you go for a geometric mean. Or when you're going to invest on a yearly basis, or you want to see year-on-year returns, you go for arithmetic mean. There you understood an important thing, that geometric mean has problem or arithmetic mean has problem, because when the data, the dispersion between the data is too much, when there are negative numbers especially, arithmetic mean gives you an incorrect answer, and therefore geometric mean is more reliable. Correct? After that, we calculated weighted mean. Weighted mean is nothing but simple weighted average returns, where we are going to take weights of the securities, multiply that with the returns of those securities. Correct? So that's the simplest formula, simple weighted average return. This is exclusively going to be used for portfolio returns. And after that, we calculated harmonic mean. Harmonic mean is a special type of mean only calculated for cost averaging. Cost averaging, right? So when you're going to invest in mutual funds in form of SIP, where the amount is equal, in that case only you can do harmonic mean, because it will tell you the cost, the average cost. So that's the quickest way to calculate average cost. Everyone cleared? Now this is what we had done till the last session. Good morning once again, everyone. Let's do with the further part. We have covered the mean. Now let's cover with the risk part, that is the dispersion. So what is dispersion? What is the first thing that comes to your mind? There is something location. I'll cover the location in a while. But what is dispersion? What is the first thing that comes to your mind when you see dispersion?
Risk.
Yes, disperse. It's called risk, correct? So risk, there are various ways to measure the risk. And the two major categories are absolute dispersion and relative dispersion. In absolute dispersion, we are just going to focus on risk. In relative dispersion, we are going to focus on risk with respect to returns. So risk adjusted returns, or you can say risk reward ratio, that is what is going to happen in relative dispersion. In relative dispersion, you are going to relate your dispersion with something. Okay. So we are going to, today's session is mostly going to be focusing on different types of dispersion. Fortunately, because we have calculator, we have all the functions in the calculator, but I'll also focus on the part of, basically on the part of how to manually do it also. Even though not required, but still we'll understand. Now, before we go from central tendency to the dispersion, in between that, we have something called as measure of location. Now, what measures of location tells us? It tells us the location of the data. And the location of the data is going to be an important part, because this approach will help us in understanding the values. And if I were to focus something here, the values at or below which a specific proportion of data lies. So where is your data exactly located? How much of your data is in what proportion? That is what will come to know from the location of the data. This is something which we may have done in the past in the quants, if you remember. That is what we call as quantiles. So in the past in statistics, you must have done this. If not, don't worry, we'll connect this right now. So let's focus on that. So yeah, okay. So now we are on the measures of location. Now the most common quantiles, first of all, statistician call this as quantile or fractal. There are different names for it. One thing you have to focus is that what it is going to give me, it is going to give me value at or below a particular data. So at or below is a major thing. When I say at or below, it always focuses on less than equal to. At this point or below that data I'm going to get. Now, why am I doing it? How is it going to help me? We will see that when we do up an example. But first of all, before going into the questions and before trying to apply it, let's understand the terms. What do you understand by median? Median? Anyone? Yes. What do you understand by median? Yes.
It divides into it's two proportions.
Correct. So median is right in the middle, right? What median does is that it divides the data, as you rightly said, in two parts, or it divides the data in half. So I can write here median, what it does, it divides the data in half, or I can write here in two parts, correct? So when it divides the data in two parts, each part will have equal proportion. So the proportion will be 50% in each, correct? Similarly, quarter, it's related to quartiles divides the data in four parts. And therefore each part will have 25%. Quintile divides the data in 5 parts, and therefore each proportion will have 20%. Decile, it divides the data in 10 parts, and therefore each proportion will have 10%. And percentile, which we all know, divides the data in 100 parts. So every part is 1%. Correct? So median divides the data in 2 parts. Therefore, each of the data, each proportion has 50. Quartiles 4 parts, quintiles 5 parts, decile 10 parts, and percentile is 1%. That is 100 parts. So can someone tell me, if I say 2 decile also means 1 quintile? Am I correct?
Yes.
See, 2 decile means 20%. It also means 1 quintile, right? If I say 2 quartile also means median. Got it? Similarly, if I say 20% percentile, 20 percentile also means 1 quintile. Got it? And when I say 25 percentile, it means 1 quartile. When I say 50 percentile, it means median. So basically, percentile is the most flexible. You can say percentile to anything. When you say 10 percentile, it becomes 1 decile. When you say 20 percentile, it becomes 1 quintile. When you say 25 percentile, it becomes 1 quartile, and so on. So most of the data is generally referred in terms of percentile, because number of percentile can be converted into any other form of quantile. Now, where is this going to be used? We are going to exclusively use this into ranking or performance, basically in investment. When you want to see the performance, not only in investment, we can also relate this when we will be doing that for CFA exam results. So whenever you want to see performance of a particular sample or a data, at that time we use quantiles. Again, unless and until I go to the example, you will probably find it difficult to understand. So I'll not go to the steps. I'll directly go to the example and show you how it is presented, and then probably things will be easier. So here we are going to calculate all the different types of quantiles. They have asked us find out fourth decile, third quintile, third quartile, and ninth decile. So fourth decile, one decile is 10%. So fourth decile becomes 40%, right? Quintile, one quintile is 20%. So third quintile means 60%. Am I correct? Similarly, third quartile will be, one quartile is 25%. So third quartile will be
75.
75. And one decile is 10%. So ninth decile will be
90.
90%. This is what we have to find. Again, until I don't complete the entire question, things will be difficult to understand. And also remember, in exam, they are not going to ask such a long question. Okay, I'm doing the long question. Probably I'm explaining all parts of it. They may ask only a small part of it. Okay, so here you have the data. The data is basically 16. They have said that the following return data is available for 16 mutual funds. So there are 16 mutual funds and we have their data, their performances. Now we are going to understand that we are going to do their performance evaluation. So these are 16 different mutual funds. Each of them have given returns. One of the mutual fund has given 2%, another 7, 0, -6, 5, and so on. You can also assume this as the marks of students, different types of 16 students. So basically, the number of data that I have here is 16 because there are 16 mutual funds. The very first thing that we always do with any type of data, if you recollect from histogram also, is that we arrange the data in order because the data is abrupt. So the first step is that we do is we arrange the data. I've already arranged the data in ascending order. The lowest one here was -10 and the highest one was +10. So we've arranged the data and we have the number of data is 16. Now the first thing we are going to find out is the fourth decile, which is 40%. So out of these 16 numbers, where, if you remember, the one thing that I told you to actually understand from quartiles is that we are trying to find the value at or below. At or below. So we have to look for values which are at or below 40%. How much of these data is below 40%? What number constitutes the data below 40%? So in order to find location, we have a formula that is n+1 multiplied by the percentile. Y is nothing but the percentile. And why percentile only? Why not quartile or median or anything? Because percentile is the most flexible. As I just told you, you can just do you can convert percentile in any other quartile. So when I say 25 percentile, it becomes one quartile. When I say 20 percentile, it becomes one quintile. So percentile is the most comfortable quantile, and therefore we in the location we take percentile. Still, hold on. You may probably be wondering what exactly is going on. Remember, the formula here is n+1 multiplied by percentile. How does this help? So for example, here we had 16 data. So here my n+1. What is going to be my n+1? I will be writing 16 plus 1, correct?
16 plus 1.
So I will be doing here 16 plus 1 multiplied by the percentile. And how much is the percentile? 40 percentile. So you write 40 by 100, or you can directly write 0.4. So now in your calculator, when you do 16 plus 1 multiplied by 0.4, can you tell me what do you get?
6.8.
Okay. So you are actually looking for a 6.8. That is your location. Neither 6 nor 7. Your location is 6.8. But if we see the numbers, we have either 6th or 7th number, right? So from the sequence, we have to see the 6th or the 7th number. So actually the location of our data is somewhere between the 6th and I can say 7th number. Because 6.8 is between 6 and 7. Now, if we have arranged the data in the order, can you tell me which is the 6th number? -10. 1, 2, 3, 4, 5, 6. I have the 6th number as -1 and the 7th number as 0. Am I correct?
Yes.
So here the location was between 6th and 7th number, and those numbers are -1 and 0. So I will write the value is between -1 and 0. That is where our value is. Now, what is the difference between -1 and 0? How do we calculate the difference? The gap, the largest minus the smallest. So if I now calculate the difference 0 minus -1, the difference is of 1. That is, the gap is of 1, correct? So where exactly is the value? Can I say the value is minus somewhere from -1 till 0? We have entire gap of one number, that is 6 and 7. So if I just plot a diagram here, your 6th number and your 7th number, your 6th number is -1 and your 7th number is 0. And where do I have to reach? Do I have to reach till entire 7th? No, I have to reach till the point which is 6.8. Correct? Are you getting it? So the entire gap is of $1 or one number. But I don't have to reach till entire gap. I don't have to cover from 6 till 7th. I have to cover only 80% of the distance, right? So if 100% of the distance is 1, how much is 80% of the distance? Why do I say 80? Because 6 to 7th, I have to reach till 0.8. Are you getting me? 100% of the distance, the gap is 1. I have to reach how much? Only 80% of the data. Are you getting it? Everyone. So can you tell me how much is 80% of the data? How much should I add? Should I add 1 or 80% of 1? Everyone?
80%.
80%, because I don't have to cover the entire distance. I have to don't go from 6 till 7. I have to go from 6 till 6.8. Correct? So the value will be 80% of 1, which is 0.8. That will be the value. And what was the value at 0.6? At the sixth one, it was -1. So plus I will do, basically my distance was -1. So -1 I will do it. So from -1, it won't go to complete 0. It will go to, if you check that calculation, you will do 0.8 -1. So your answer will be 0.2 negative. Now what it tells me that till this point, the value is -0.2. Okay. Still, there must be some confusion that what exactly we are doing. Now what it tells me that between this data, between -1 and 0, now understand very carefully what we've calculated. Otherwise, you'll be lost in the calculation. So between these two data is -0.2. Now the question is, what we were doing, we were trying to find the location of the data, and they had told us to find 4th decile. So I can say at or below. If you remember at or below, I will now conclude all those who have scored less than or equal to 0.2 at or below, right? So at -0.2, 0.2 or below. So all those who have scored -0.2 or below, they fall in the bottom 40%. They fall in the bottom 40%. So they had asked 40% of the data. So let's say there is a 100 percentile data. How much is at or below 40%? Those are all those who have scored less than 0.2 or 0.2 or less than 0.2 negative. All those who have scored -0.2 or below that number, they all constitute the bottom 40%. Clear, everyone? Everyone understood the location?
Yes.
Now, in the same way, if I have to now go third quintile, one quintile is 20% and the third quintile is 60%. So my location, the formula again is the same, that is n+1, that is 16 plus 1 multiplied by 0.6. How much will it be? 16 plus 1 multiplied by 0.6.
10.20.
10.2, right?
Yes.
So my number is between 10 and 11th. So I will choose the 10th and 11th number. And now if you go on the screen, your 10th and 11th number, we will choose. Where is that 10th number? 1, 2, 3, 4,
2 and 3.
7, 8, 9, 10. 2 and 3. These are your 10 and 11th, right? So my value is between 2 and 3. Now between 2 and 3, the difference is 3 minus 2. Again, the difference is same plus 1. But I don't have to cover entire 100%. I have to cover only 20%. Why do I say 20%? Because the 10th number and the 11th number, I have to reach till 10.2. You know, the unfortunate thing is that the location is not in a proper manner. When I say location is not in a proper manner, the actual data, we may come across situation where the location is not a whole number. So it is not 10th nor 11th. Had that been the case, then we would have just picked up that number, right? But the irony here is that the location that we are looking is not a whole number. It is 10.2. Like in the previous case, what we had is, we had the number 6.8. Now, these are the reasons due to which what happens, due to which perhaps you have to apply the location formula. Okay. So I will just come to this point. Yeah. When dealing with actual data, we may come across a situation where the location is not a whole number, or where we may not find any observation that divides the sample exactly. So we are not exactly able to get the 10th or the 11th number. Now, therefore, in such a case, we use the approximation stuff. We use an interpolation. The formula, therefore, to find the percentile in the array with n entries. N is the number of data. Sorted in ascending order. So you first arranged it in order. We arranged the number, it's in order. And then we found the location. Correct? So why are we doing this? Because the location is generally not a whole number. If it gets a whole number, nothing like that. For example, if the location was 6 directly, then I would have picked up the 6th number, which was -1. That would have been my location. But if it is 6.8 or 10.2, then you may have to do the calculation. So here, in order to reach 10.2, what is the 10th number? The 10th number is 2. The 10th number is 2, but I have to reach till 10.2. So I have to add 20% to the distance. What was the distance here? Again, the distance was 1. So now I will do 20%. Why 20%? Guys, because I have to go 10.2. Between 10 and 11, I just have to cover 20% distance. Plus, I will cover the 10th number, that is 2, and my answer will be 2.2. Now, what does this conclude? It concludes that in the bottom 60%, how many people are in the bottom 60%? All those who have scored 2.2 or below. All those who have scored 2.2 or below are in the bottom 60%. Got it? Why do I say always bottom? Because it is at or below. Clear?
Yes.
Now, just for a fraction of a second, assume this is CFA Institute exam numbers. And these were 16 students. Okay. 16 students have got these marks. Someone has got -10. Just assume that there is negative marking also. Fortunately, in CFA, you don't have a negative marking. But assume these are the negative markings. And CFA Institute tells you that all those who are in the top 25 percentile will pass. So can I say all those who are in bottom 75 percentile will be fail? Correct?
Yes.
Now, how do I calculate who's got, who's in the below 75, in the bottom 75 percentile or in the top 20 percentile? This is where I use the quantile functions. So I have to find that number below which, if I've scored that number or less than that, I am failed. So I want to see all those who fall in the bottom 75 percentile, because the top 25 percentile are only pass. So I have to focus on the bottom 75 percentile, right? So first of all, the third quartile, that is 75 percentile. Let's calculate that. So my calculation, yes, anyone can help me. 16 plus 1 multiplied by 0.75. And if you calculate this, you'll get 17 into 0.75, you'll get 12.75. Am I correct?
Yes.
And therefore your location is between 12th and 13th number. And let's check what is the 12th and 13th number. We have the 10th and 11th as this. So 12th and 13th number is anyone? 12th and 13th number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5th and 6th. Between the values between 5th and 6th. And the difference between 5th and 6th is plus 1. So 1 into 0.75 because I have to go 7 plus the 5th value. So my answer is going to be 5.75. What does this mean? Can anyone tell me? What does this mean when I say 5.75?
Anything below
Yes.
or at 5.75
How many? So all those who have scored, yeah,
like scored 75% are below or at 5.75.
correct. So I can say all those in the bottom 75 percentile are all those who have scored 5.75 or less than that. Correct. So let's assume we had the data. This is the data, 100% data. So 0 to 100 percentile. And we are looking for the top 25 percentile because only those we consider as pass, right? So what is the score? I can say all those who have scored 5.75 or less than that, they are in the bottom 75 percentile. So if your score is 5.75, more than 5.75, then you are pass. So if you now look at the screen on the top, 5.75, more than 5.75, I can say I have the numbers, these numbers. So these are the guys who have passed. All others have failed. 6, 7, 9, and 10. Correct? So all those who have scored 6, 7, 9, 10, they are passed, and the others are in the bottom 75 percentile and they did not pass. Got it, everyone? Now, you can relate this as a performance of a student or a performance of the fund managers. So I can say who are in the top 25 percentile fund managers. All those who have scored 6, 7, 9, 10, they are in the top 25. And all those who have scored less than 5.75, they are in the bottom 75 percentile, right? So if I have to award best fund managers, top 25 percentile best fund managers, I would award the last 4 ones. Clear? Everyone? So now in the same manner, can you find the last one? 9th decile, everyone? 9th decile means bottom 90 percentile. So we are actually focusing on the top 10 percentile. So we are trying to find the location of all those people who are in the bottom 90 percentile, right? So this will be 16 plus 1 times 0.75. Anyone with the number? 16 plus 1.
15.30.
Sorry, not 0.75, 0.9, right?
0.90.
Correct, sorry. So you have 15.3. So the location is between the 15th and the 16th number, and these are the last number, right? So that is 9th and 10th. 15th and 16th number, that is 9th and 10th, right? So we will write the values between 9th and 10th. Sorry, 9 and 10. And the difference between 9 and 10 is again plus 1. Not necessarily always the distance is plus 1. At times the distance can be more than that also. So our value will be 15.3. So 30% of the difference. So I will do 1 into 0.3 plus 9. So our answer will be 9.3. So my conclusion will be, in this case, all those who have scored 9.3 or less than that are in the bottom 90%. Correct? 9.3 or less than that are in the bottom 90 percentile. Or I can say all those who have scored greater than 9.3 are in the top 10 percentile. Clear? Everyone? Correct? So in this way, we find the location of the data. First of all, you have to find the location, that is n plus 1 multiplied by the percentile. Then you get to know where the number is, between which number, fifth or sixth, between fifth or sixth. If you get rounded off answer, nothing like that. But if you don't get a rounded off answer, then you may have to interpolate. And for interpolation, what do? We just see the difference, the gap between the numbers. And in that gap, we do the interpolation. We do proportionate calculation. And then we add to the lowest number to find the location of the data. Our conclusion in the last 90 percentile, I'll repeat, all those who have scored 9.3 or below that are in the bottom 90 percentile. Or the reverse you can also use, that all those who have scored more than 9.3 are in the top 10 percentile. Correct? Clear, everyone? So this was just one part before we go to the dispersion. That is what location was. Now, as I said, we are now going to focus on the measures of dispersion, that is risk. And there are two types of risk, absolute and relative. In relative, we are going to relate the risk with something. The easiest form of measurement of risk that generally people use is range. What range tells you? The difference between the largest and the smallest number. The difference between the maximum and the minimum value. The range, the thing about the range is that it is the easiest to calculate, but the problem with the range is that it just focuses on two numbers, that is the largest and smallest. So it is only two pieces of information. It cannot tell us the distribution of the data. It does not tell us how weird or how much the data is, what is right in the middle. We don't understand anything. So the range only focuses on two information, the largest and smallest, and that's also the disadvantage. Because if there are extreme large or small outcomes, and these extreme numbers, large or small, they are also called as outliers. We'll see that again in the future also. So when there are extreme numbers, right? So then the range may not be a correct picture. It may give us a very wrong picture about the data. And therefore, we also look at the other forms of measurement. The other form of measurement is called as mean absolute deviation. So first is range. The second is mean absolute deviation. Now, before I explain you mean absolute deviation, let us see this particular example. What is this example? Here you are given calculate range and MAD. MAD is mean absolute deviation. As of now, I have not explained you anything about the mean absolute deviation. But the simplest form is range. What I'm going to look in the range is the smallest number and the largest number. The smallest number here is -6 and the largest number is 10. So the difference between the maximum and the minimum value, that is 10 minus -6, 16 is the range. Easy, everyone? Range is no issues, right? But yes. How to calculate mean absolute deviation? That is very important. Mean absolute deviation. Now for that, I first need to calculate mean. If you remember mean, population and sample. Simple arithmetic mean, what are you going to do? You are going to do the total of all, divide that by the numbers. How many numbers do I have here? 1, 2, 3, 4, 5, 6, 7. 7 numbers I have. So what you are going to do right now in your calculator, everyone with me, just press 2 plus 7 plus 0 minus 6, 5, 10 and -4. And let me know the total. What is the total? Add 2 plus 7, 9, minus 6, plus 3, plus 10, minus 4. Let me know what is the total.
14.
Hello? Yes?
14.
14. And if I divide that by the number of data, The number of data I had is 7. You can say 7 years or anything. So 7, when I divide this by 7, I get the average, that is mean. And that is nothing but 2% in this case, correct? So if these are returns, I can say my average return is 2%, correct? Now, what is the meaning of dispersion actually? Dispersion. Now, let's say you present this to the client and your client tells you that, okay, what is the average return from this stock? Let's assume this is a stock. Okay. So you say, sir, the stock has on an average given me the return of how much? On an average, the stock has given me return of 2%. Why do I say on an average? Because at times the return, if you see your, let's say if these were yearly data, I can say, sir, at one particular year it had given 2, then 7, then 0, -6, and so much. So I've calculated an average, and on an average, I conclude that the return is 2%. Now, as soon as I present this to the client, my client will tell me, Kunal, that you tell me it is 2%, but I hardly see 2% here. There's so much of deviation from 2, isn't it? The data goes haywire. From 2, it has gone to 10 also, it has gone to -6 also. So the next question that the client is immediately going to ask me that, how much do you think, what is the possibility of 2? Are you sure that you'll get 2? What is the guarantee? So then my answer will be that, sir, there will be some deviation in it because this is on an average. And immediately my clients, because my clients are going to be smart, they're going to catch my words. So they're going to tell me that, Kunal, you said the average is 2% and there will be some deviation from 2. How much will be the deviation? Are you sure? Are you going to guarantee 2%? I say, no, sir, I cannot guarantee 2 because there will be some deviation. So now they are interested to know how much it can deviate from the 2. How much it can deviate or go away from 2. So if you see the number, I will check it I'll check each and every number and I will see how much is it away from the mean. And that is what we call as x minus x bar. What will x minus x bar do? It will tell me the distance of the number away from the center. When I see distance away from the center, that is what we call as dispersion. How much it is away from the center? Are you getting it? How much is my data away from the mean? That is what we call as dispersion. So guys, with me, if I want to see the first number, how much is it away from the mean? The mean is 2, right? So I can conclude this is 0. How about the second? I will do 7 minus 2. Then I will do 0 minus 2. Then I will do -6 minus 2. Everyone. Then I will do 5 minus 2. 10 minus 2. -4 minus 2. And if you calculate with me, guys, 7 minus 2 is 5. This is -2. This is -8. This is 3. This is 8. And this is -6. The last one. Guys, can you quickly calculate that? And let me know what is the total of everything. You'll find a surprising thing. I want everyone to calculate this and let me know what is the answer, the total of all.
0.
0.
It's 0. Why? It will always be 0. Do you know why? Because you are right in the center and you're telling me what is the distance from the center. Well, from the center, it is always equidistance, right?
Yes.
So if I take all the numbers from the universe, let's say I take all the numbers from the universe, right in the center, I have 0. If I were to take what is the distance of 1 from the center, which I say -1 and +1. And if I add them, it will always be 0, right? -1 and +1. What is the problem? The problem is that whenever you calculate the distance from the mean, if you calculate the distance from the mean, it will always be equidistant. And therefore, I can say the negatives will set off the positives. Isn't it? So does it mean that there is no dispersion? When you got an answer of 0, can I say that, sir, no, there is no dispersion? Is it? Yes or no? Does
No.
it? There is no dispersion. No, there is dispersion, right?
There is, yes.
And therefore, in order to get rid of this problem of negative, why negative? Because the negative offsets the positive, right? In order to get rid of this problem, what we take is we take the absolute values. What is absolute values? You see this bar here? This bar will ensure that we take the absolute values. Absolute values means we ignore the sign. So wherever you have got negative, for us, that is, we have to ignore those signs. Got it? Therefore, it is called mean. Why mean? Because we are going to take average of it. Absolute. Absolute means ignoring the sign. Those bars that you see, they are called absolute. Deviation. So this is called mean absolute deviation. Why is it called mean absolute deviation? Because we are going to take the mean, that is average, of absolute deviation. We are going to ignore the sign. Why are we doing it? Because if we don't do it, what will be our answer? Our answer will be, unfortunately, always 0, which is technically not correct. Everyone with me? So what I've done is that, guys, take a note of this, the formula, that we took x minus x bar, correct, to find the distance away from the mean. How much is every number away from the mean? But if we simply take the summation of it, the total of it, we'll always get 0. And therefore, we took the absolute value of it, that is without the sign. And then we averaged it out. How will we average it? By dividing by n. Correct? Now, if you check the total, 5 plus 2 plus 8 plus 3 plus 8 plus 6. What is the total in this case, guys?
32.
32. And when you divide 32 by 7, you will get a number which is in some percentage. 32 divided by 7 is how much?
4.57.
4.57 percentage. Now, if I tell my client that, sir, on an average, the return from the stock is 2% with a deviation of 4.57. When I say 4.57 deviation, it means plus minus. Why do I say plus minus? Because it can go plus 4.57 up or plus 4.57 down. Got it? On an average. Everything is on an average. Clear? So guys, the conclusion is that it can go up as well as down, right? So just randomly, if you add 4.5 to 2, it can go to 6.5 on the upper side on an average. And on the bottom side, if you subtract 4.5 from it, so it can go to negative 2.5. Am I clear, everyone? How did we calculate and why did we do all this thing? Why did I not take simply the summation of x minus x bar? Why did I take the absolute values? What if I don't take the absolute values? What would happen? My answer would be always 0 and it will show me a wrong picture. Clear, everyone?
Yes, sir.
So here now, let us read the concept. What is mean absolute deviation? If we compute the arithmetic average of the deviation around the mean, it will always sum to 0, isn't it? Correct? Therefore, then, and why is that the case? Because the negative deviation cancels the positive deviation. And therefore, in order to get rid of this problem, we calculate mean absolute deviation. What do we do in mean absolute deviation, guys? In the calculation of MAD, which is mean absolute deviation, we ignore the deviations around the mean. So we ignore actually the sign, I should rather say. So we ignore the signs here and we take the absolute values. And that value will be our mean absolute deviation. Clear? Right? No. One more small thing, if you understood this. Now just assume instead of 4.57, if the dispersion here was 14.57, what is your first thought? If instead of 4.57, if I were to say that there was another stock, let's say another stock, it had also the same numbers, but instead of 14, it had instead of 4, it had 14.57 as the absolute deviation. What is the first thought coming into your mind?
A riskier asset.
Very good. Riskier. Why riskier? Because now it can go to plus 14.5 or to minus 14.5. And this is what is a very important thing. Remember, risk. Traditionally, what are we taught? We are taught always that risk means loss. But finance tells us that risk is not loss, risk is uncertainty. Uncertainty means uncertainty of something beyond your expectation. So I'm expecting the average return of 2, but I getting more than 2 or less than 2. Both are risk for me. Okay. And the higher the deviation, higher is the risk. Higher the dispersion, higher is the risk. So guys, the conclusion is here, the risk is not always a negative number. Risk is not always the one which goes below a mean. Risk is anything which is uncertainty. Remember, risk is not loss. Risk is uncertainty. Uncertainty of, you are expecting something and not happening of that thing is called risk. So I was planning to go to the exam and score 70. That is my expectation. Now, if you have a 10% dispersion, means you can score 80 also, you can score 60 also. Both is risk. Of course, you like the upper risk more. You would want the higher number always. You don't like the lower number. But risk is always how much is the deviation from your expectation? How much is the deviation from the mean? Higher the deviation, higher is the risk. Higher the dispersion, higher is the risk. Correct? So from now, remember always, risk is not dash, but dash. Risk is not always loss, but risk is uncertainty. Correct? So next time when someone tells you it is risk, risk does not mean loss, risk means uncertainty. Uncertainty can be in your favor, can be against, but your appetite, your potential to your ability to bear the risk is what will decide your future. So risk can be on the positive side, also on the negative side. Higher the deviation, higher is the risk. Clear? So can someone tell me, why did I take the absolute numbers? What would happen if I don't take the absolute numbers?
The answer will come to 0.
Answer will always come to 0, correct? So therefore, we took the absolute numbers. Now, in absolute numbers, we ignore the sign. Is there any other way of taking or any other way of getting rid of this problem of negative? Is there any other way that comes to your mind? Yes. The other way of doing it is taking the square of the numbers. Is taking the square of the numbers. And when you do the square of that, it is called variance. When you do the square of it, what is that called as? Variance. Now, what is variance? We will see that. But we got these numbers, right? From the example. If I do the square of all, what will I get? Let's check. And while we are calculating the square, you all will also keep on adding them, right? So when I had got the average of 2% as my average return, right? Correct? Now guys, I've written here the average as mu. What does mu stand for?
Population mean.
Population. So right now we are focusing on population, correct? So here I have taken all the numbers, but I have to, the another way of getting rid of the problem of negative is doing the square of it. Square of any number is positive, correct? Everyone? So if I now take the square of this, let me take here, it will be 0, here it will be 25, 4, 64, 9, 64 and 36. Guys, just add all the numbers.
202.
Sorry, 202, right? What is this 202? This is, you know what? X minus mu. Mu is nothing but the average. The whole square. Why did I do the square, guys? Can someone tell me why did you do square?
To avoid the minus sign.
To avoid the minus sign, correct. And then we did the total of it. That is 202. And since we are going to take average, I'm going to divide this by number of data, which is in this case 7. And when you do this, you get a number. So 202 divided by 7, you'll get an answer of yes, anyone?
28.85.
28.85 is your answer. Now, guys, these were returns, correct? Returns. So I will write here 28.85 percentage, but since we took the square of it, this answer will also be 28.85 percentage square. Now, what is your average return? Your average return was 2%. And what is your risk? 28.85 percentage square. If you tell your client that your risk is 28.85 percentage square, you would run away. Why? Because you would not understand what is percentage square. Why is your answer in square? Because you did the square of everything, isn't it? You did the square of all the percentage, correct? So this square, which is actually the answer, that is called variance or variance, whatever it will be called. But the problem with variance is that it is in percentage square and you have to compare. Normally a client compares risk with return, right? The return is in percentage and the risk is in square. So what should I do?
Take a square root.
We should take the square root so that the percentage square becomes percentage, isn't it? So in your calculator, when you press square root, what you are going to get is the answer in percentage, and that answer is called standard deviation. How much is your answer, guys?
5.37.
5.37. So what you did is that you took x minus mu. Mu is the mean, the whole square. You did the summation of it, and then you divided it by n. What you get from this is called variance. But the problem with variance is that its answer is in percentage square, which is difficult to relate with the mean, which is in percentage. And therefore, we take the square root of it. And when I do the square root of it, I get the standard deviation of the data. The data is x. Everyone. In mean absolute deviation, you took the absolute values. Here, you're taking the square. Why am I taking the square? Because, guys, I want to get rid of the problem of minus. If I don't do that, my answer will be 0. Clear, everyone? So here, what did we do? We did first x minus x bar. X minus mu, because it's a population. Correct? The whole square. We did the summation of it. We divided it by n. Therefore, we get variance. So if someone tells me how do I calculate the variance of x? I will do x minus mu, the whole square, its summation divided by n. This is variance. But the problem with variance is that it gives me an answer which is in percentage square. Variance will give me an answer in percentage square. So x minus mu, the whole square divided by n. This gives me an answer in percentage square. And the problem is that your return is in percentage, your risk is in percentage square. It is difficult to relate. So what I can do is that if I do the square root of all of this, my answer will be in percentage and it will become standard deviation of x. So standard deviation of x is nothing. Variance is in square terms, standard deviation is in square root terms. So when you do the square root of variance, what you get is standard deviation. Everyone with me? Clear? Now, this is what we've done for population. We are going to do the same for the sample. There's only minor difference. But let's understand what is variance and standard deviation. So a second approach to the treatment of deviation is to square them. Why second approach? Because the first approach was to take the absolute values. The variance and standard deviation are based on squared deviation and are actually the two most widely used measures of dispersion. In fact, in practical life, what you are always going to come across as risk by default, whenever we say risk in finance, it is always standard deviation. By default, whenever we say risk in finance, it is always standard deviation. But remember, standard deviation comes from variance. So you first calculate the variance, then do the square root of it, and then you get the standard deviation. Everyone, correct? When you're doing it for the population, you refer the mean as mu. Everyone, correct? Here, one simple thing is that when I do the square root of it, I get a deviation. So the square term is called, guys,
Variance.
And the square root of it is what we call a standard deviation. Clear, everyone? Okay. Can the variance, answer me this very important question, can the variance be negative?
No.
Can the variance be negative? Well, it can never be negative. Why? Because I'm always doing square, and the square of any number is never negative. So, another question, can the standard deviation be negative?
No.
Why? Because standard deviation comes from the variance. If the variance is not negative, standard deviation can never be negative, isn't it? Everyone?
Yes, sir.
So these are the things that the CF Institute may ask. Okay. So risk is always a positive number. A variance or standard deviation is always a positive number. It can never be negative. Correct? Everyone? Now, whenever you go for investments, you will always be focusing on return, that is mean, and the risk, that is standard deviation. However, remember that in order to calculate risk, you will first have to calculate the variance and then convert it into standard deviation by doing the square root. Correct? So first you will come across variance, the square terms, and then you do the square root of it, you get the standard deviation. So in our example also, if you recollect here, we did the square of everything. If you don't do the square, we'll get our answer 0. Then we get variance, and then we convert that into standard deviation. Clear? Everyone? Now,
Yes, sir.
Now one more thing. This is what we did for population because we had mu. However, when we do for sample, instead of mu, that will be replaced with sample mean. And what is sample mean referred as X bar? Correct? So the visible difference that you see will be, instead of mu, now it is replaced with X bar. Am I correct? But have you noticed one big difference compared to the formula of population to the sample? What is the big difference that you must have noticed? Apart from the terminology, see, the terminology is here. Population is referred to as sigma, sample is referred to as S. Remember this, okay? Population is referred to as sigma, population risk is referred to as sigma, population mean is referred to as mu. I'll write here. If you want, I'll write here. So mean and standard deviation for population, for sample. For population, we refer the mean as mu. For sample, we refer as X bar. In terms of standard deviation, population is referred as sigma and standard deviation is referred as S. Okay. That's the change in the terminology, nothing big. But have you noticed other big difference in the formula? The biggest
n-1.
Yes. In sample, in the denominator, you don't have n, but you have n-1. Everyone. That's the biggest difference. Whenever you have a sample, it is always in the denominator, it is always n-1. Why? I will tell you from this example. Now, this example that we did, you didn't know whether it's a population or a sample, correct? What if I say this is population, then these are your answers. But what if I say this is the sample? And if you divide that by n, won't your answer be the same for population and sample?
Yes.
Now, what does this conclude? This concludes that the risk of the population and the sample is same. But guys, tell me one thing, and this is very, very crucial. Okay, this is the actual reason that we are doing CFA, is to understand the not what is written in the lines, but between the lines. And so focus on answering. What is more riskier, population or a sample? To answer that or to understand that, you have to go to the some section back and recollect, why are you analyzing the sample? Why do you look out for the sample? Where is the need to analyze the sample? Why do you look at sample rather than the population? Can you tell me?
Population is big, like
A bit loud if you can. Yes.
population math, it's kind of a big, so you just get an overview, so you use sample.
Correct. So the reason you said is population is large enough. So I can say analyzing the population is difficult, costly, and at times not even possible.
Yes.
But tell me one thing, if I take the entire population, let's say there are 500 shares in a particular exchange, and you're taking a sample of 50. Okay. So if I take all the 500 shares, and that is a population, if I take a sample of it only 50, I'm analyzing that, then it's a sample. So the reality is that the population risk is actually relatively lesser. Why? Because it considers all the members, and the sample is not exactly as the population. The number of size of the sample matters a lot. The sample will closest resemble the population. Remember this and listen this carefully. The sample will closely resemble the population when the number of n increases. So a sample of 50 out of 500 will not exactly represent the population. But if I increase the sample size, it will closely resemble the population, isn't it?
Yes.
So larger the size of the sample, the better it is. The larger the size of the sample, the more closely it resembles the population. Correct? And vice versa, I can say lower the size of the sample, the more away it is from the population. Everyone with me on this? I'll repeat. What? Larger the size of the sample means larger n. Larger the size of the sample, the more closely it represents.
Closer it is.
But guys, lower the size of the sample, the more further it is away from the population. And therefore, we need to adjust this disadvantage, you can say, about the sample. We need to adjust this, and how this is statistically adjusted is by concluding. First of all, tell me one thing, because of this, the point where the sample is smaller than the population, what is actually more riskier? The sample is actually more riskier than the population because the size is small. So the sample should be riskier than the population. I'm not talking in total terms, I'm talking in average terms. The sample risk, the sample deviation will be smaller. The sample deviation will be smaller only and only if the number of sample size increases. But lower the sample size, the lower it will, the lower the sample size, the more riskier it is, the more deviation it will have. And therefore, in order to adjust that, what do? We divide it by n minus 1. Instead of dividing it by n, I divide it by n minus 1. Guys, if I divide this by n minus 1, so here, if you recollect, our total was how much? The total of our variance the total of variance, that is x minus, now I will say x bar, correct? So that was 202, correct? Now instead of dividing that by 7, I will divide that by 7 minus 1, which is 6. Will my answer increase or decrease? Will my variance answer will
Increase.
Increase. Can you tell me how much is the answer now?
33.67.
33.67 square, and when you do the square root of it, your answer will be slightly higher, 5.80 percentage. So your variance is 33.67 percentage square, and your standard deviation is 5.80 percentage. Your risk has slightly increased, and that has increased because of it being a sample. And why? Because I divided it by not n but n minus 1. Why n minus 1? Let us read that. That is very, very important, and CFA Institute is famous for asking this. For sample variance, we divide the sample size by n minus 1. So sample size minus 1, and that is called as degree of freedom. Degree of freedom is nothing but the actual size that you take. So degree of freedom is n minus 1. It is also referred to as n minus 1 is also referred to as, guys, degree of freedom. Why do we do this? By doing this, we improve the statistical properties of sample variance. We improve the property. What do I mean by we improve? We take a conservative approach. When I say we take a conservative approach, means that we don't assume that the population and sample risk is same. We say that since the sample is not exactly the population, our sample is slightly riskier than the population. I'll repeat. We say we take a conservative approach, which means that since our sample is not exactly as the population, we say the sample is slightly riskier than the population. So we say that the population will be better, sample is slightly riskier. That's how we analyze. We take a conservative approach. So it's like, you know what, when a client tells you that what can be the risk, instead of saying lower risk, you say that, sir, this can be the maximum risk. So that's what we do with sample. So in statistical terms, sample variance is defined as unbiased estimator of the population variance. So this unbiased estimator means now after you doing n minus 1, if you do n minus 1 divided by, your sample risk will be slightly higher than the population, correct? Now we show a true picture to the client that, sir, the risk may be slightly higher, risk may not be lower because we are taking the sample. If you do this, it is called unbiased estimate. If you don't do this, then it is called a biased estimator. Now, what is biased and unbiased estimator? We will see that in the later topics. I think reading number 10, we have sampling. In that, we will do this detailed discussion about this in the sampling topic. But if the CFA Institute asks you that, where do you need to take n minus 1? In the population or in the sample? Your answer will be in the sample. Why? First, to improve the statistical property. Why do you improve the statistical property? Just think the reverse. If you don't do it, then the population and the sample risk will look same, which is not a correct thing. The sample is slightly riskier because it is not of the same size as of the population. Correct? And therefore, in order to have an unbiased estimator, these words are important and therefore I'm highlighting there. Therefore, to have an unbiased estimator, whenever we take the sample variance, we divide it by n minus 1 instead of n. That's the only difference. Am I clear, everyone? Anyone, any questions till this point? Clear? So the method of calculating population or sample mean is same. The only difference is in the risk, the standard deviation or the variance of the sample. Instead of dividing it by n, what do we do? Divide it by
n minus 1.
N minus 1. Now tell me honestly, how many of you are wondering that, are we going to do all this manual calculation in CFA? Why do we have the calculator? What do we have the calculator for? All these numbers that you've seen, I've made you do the manual stuff. There is a reason why did I do that. But all this number you just have to plug into your calculator and get the answers. Are you ready to do that?
Yes, sir.
Okay. So everyone in your calculator, what is there in your calculator behind 7? See in your calculator here on the background of 7. 7, yes.
Currency.
What is that you have here? Just behind 7, you have data. If you see in the yellow one. So what everyone is going to do with me is that press second 7, that is data. You know here, whenever you press second and any number, it works like shift. When you press shift, let's say shift 2 or shift 3, it takes the number behind that, right? So here that second works like shift. Okay. So when you press second data, it takes second 7, it takes the data. What do you see on your screen?
X1.
So X1, first of all, if there can be at times a number in X1 or there cannot be. So in order to understand that, what you need to do, you need to press down arrow and see if there is any number or not. Is there any number?
No.
No. If there is any, it is better always to press second clear, second clear, second clear, second clear. Correct? Everyone. Now let's go to our data. So you have pressed second 7. On your screen, you have X01. Correct? What is 01? That is the first data. Here you have how many numbers, guys? 7 numbers. So we are going to put them. So in X01, I will put 2. So press 2 and press enter. What do you have next on your screen? I hope everyone is with me.
Yes.
What do you have on your screen, guys?
Y01.
Y01 means second variable. Do you have second variable? No, you have only one stock here, right? So here you will, if you skip it, it is by default set at 1, isn't it? So just
Yes.
press down arrow and press the second return. What is the second return here? 7. So I will press 7. So 7, enter, press down arrow again, 1, enter. Then the third return is 0, minus 6 and 5. So I will do 0, sorry, minus 6 and 5, 10 and minus 4. 10 and minus 4. Correct, guys? And wherever you see Y, it is by default set at 1. Everyone. Now, when you go to Y07, after that, Y07 is automatically at 1. Am I correct? Okay. Everyone done?
Yes.
Now, guys, when you press second 7, just behind 7, you had something called data, right? Now,
Yes.
see what is there behind 8?
Statistics.
Stat. Correct? So now press second 8 in your calculator. Second 8. Now everyone has to tell me what is there on your screen, because if you don't tell me, you'll never understand this concept. What do you see on your screen? Please tell me, everyone.
LIN.
Okay. Someone has LIN. Everyone has
LIN.
Lion.
LIN. Everyone?
Yes, yes.
Okay. Now LIN is linear. Now here we have only one variable. So we have to change this. How do we change this? See, first listen carefully. You have to press second and enter. That's what you have to do. So press second and enter. Once you press that, you will have on your screen ln.
Yes.
Yes.
I don't need ln. I need one variable. So you have to keep doing second enter till you get one v. So again, press second enter. You have exp. Then you press second enter. You have pwr, and then you press second enter. You will have one v.
Yes.
Everyone has got one v on the screen. Everyone with me?
Yes, sir.
Now press the down arrow key and tell me what are the numbers that you have. The first number you will have is n. That is your n.
7.
7.
7,
Yes.
correct? What is your n is 7, that is the number of data, correct? What is x bar? X bar should be 2.
Yes.
Everyone? Then on your screen you have sx or sigma x. What is the first thing that you have?
SX.
Sx means sample.
Sample.
S means sample, right? You must be having the sample risk as 5.80. Am I correct?
Yes.
Everyone? What is the next thing? Come on, tell me. Just press down arrow.
Sigma.
Standard deviation.
So what is the standard deviation, guys?
5.37.
You have the population standard deviation, 5.37, correct? Guys, you have all the
Yes.
numbers ready. See, just check. The sample we had 5.8%. The population we had 5.37. Our mean was 2%. Our number of data was 7. You don't have to do all this manually. What we've done here, you don't have to do it. The reason I did is just to help you understand why do we do x minus x bar? Why do we do square? Why do we divide it by n for population? Why do we divide it by n minus 1? Are you with me, everyone?
Yes, sir.
Clear, everyone? But you don't have to do manually. You just have to go second 7, that is data, put up all the datas, and then you press second 8 and you get all the numbers that you want here. Just by going to 1v. 1v is crucial because 1v is one variable. Here you have right now one stock. So we do this. When you have two stocks, I'll tell you what to do. Clear, everyone? So can someone tell me what are the different measurements of dispersion that you have done till now?
Variance and standard deviation.
First, range. Range, the easiest, but the most not used. Why? Because it does not cover too much of data. It just covers the first and the last number. Then you did the mean absolute deviation. Everyone?
Yes.
Can you tell me what was mean absolute deviation? Where you took the
Absolute values.
absolute values. So what was your formula in mean absolute deviation? Mean absolute deviation, x minus x bar, correct? And did you take the summation of it directly? No, you took the summation of its absolute values and divided it by n, correct? Why did you do it? If you don't do it, then the total would be 0. So one way of getting rid of that negative property is taking the absolute values. The other way is to take the square of it. So we did x minus mu. Mu can be for population.
Yes.
So x minus mu the whole square. And then the summation of it. This is how you get the variance divided by n. This is called variance. And if I do the square root of this, guys, I will get standard deviation of x. Correct? If I want to find the sample standard deviation, then what would be the difference, guys?
N minus 1.
Yes, then my formula will be, first I will see the way I write the formula. The way I write the formula is I remember it forever. First of all, what did we do? We do x minus x bar. X minus x bar in the table. Then you do the square of it. Correct? See this. You did first x minus x bar. Then you do the square of it. Then you do the total of it. So I will do x minus x bar the whole square summation. Correct? Then you divide it by n minus 1. That's where you get variance, the average variance. And in order to convert standard deviation, you do the square root of. Clear, everyone? Range, mean absolute deviation, population variance and sample variance, or population standard deviation and sample standard deviation. The only difference between population and sample is in the denominator, which is n minus 1. In exam, don't worry, they will tell you whether it's a population or a sample. Most of the times you will have sample, so you will divide it by n minus 1. Clear? And how do you have to do it? You just simply have to plug in all the information and get the answer. You don't have to manually do it. However, I've just explained you how to manually do it. Any doubts till this point? Anyone? Don't worry, we'll be doing much more sums to get practice with the calculator function. The next question perhaps we'll do is somewhat related to that. Everyone, the reason I've showed you all this manual stuff is you're not going to do all this in exam. You're just going to plug everything in the calculator. But you should know that why were we doing it? What if we don't do the square of it? Then we would get the answer as 0. How do we get variance? How do we convert into standard deviation? All this reason I've showed you is that even if you at times you may not have to use the calculator, you may have to manually do it. So we are prepared for it as well. Clear? Any doubts till this point, anyone? No? Okay. Let's take a 10-minute break, guys, and then come back and do the rest of the things. Okay?
Yes.
Let's take a 10-minute break.